All right, continuing the notes for section 3.3. The factor theorem states that if x equals c is a zero of the polynomial, x equals c is a zero of the polynomial if and only if x minus c is a factor of the polynomial. X minus c is a factor of the polynomial if and only if the remainder when dividing by x minus c is 0. So it feels like there's kind of two things here. Not sure why that is, but whatever. The idea is simple. If you divide 12 by 2, your remainder is 0. That tells you that 2 is a factor of the polynomial. 2 is a factor of 12. Whenever you divide it, you get a remainder of 0. The idea here is that these things all kind of mean the same thing. So if you recall before, if we said x equals 2 is a 0, then an x-intercept is 2, and x minus 2 is a factor. We even mentioned this in the notes before and kind of said these are all equivalent statements. These all mean the same thing. I guess that's what this factor theorem is saying. It's saying if you have a 0, then you know this is a factor. If this is a factor, then when you divide it, the remainder is going to be 0. And what we're getting at here is that the remainder is actually the function value, which we'll cover here in a second. So for this thing here, just kind of remember that these three things are synonymous. If it's an x-intercept, it's a 0. If it's a 0, it's a factor. If it's a factor, when you divide, the remainder is 0. That's what it means to be a factor. Okay? Synthetic division. All right. This process that we did right here, we are going to do a lot. We are going to divide by x minus some constant, for example, x minus 4 or x plus 2. We're going to do these types of divisions a lot. And every time we do it, if we do long division, we got to do this entire process here. Well, there's a shorter process. Essentially the same thing, but kind of a shortened version of it. So this is called synthetic division. So here's how you do synthetic division. I'm just going to do it, and then we'll talk about why it works and why it's the same thing. So we're just going to take the coefficients of my dividend. 2. Now again, if there's no x squared, you have to put a placeholder in for a 0 for the placeholder. Minus 30, minus 8. So these are just the coefficients of my dividend. Then I'm going to draw a little division structure here where I have room here for a set of numbers. And then I'm going to put this 4 right here. The factor is x minus c. I'm putting the c value here. So if you see an x minus 4, you're kind of taking the opposite of the negative 4 and putting a positive 4. So here's the process. We're going to bring down the first number, 2. Just bring it straight down. I don't like, some people put that symbol there. I don't. Just bring the 2 down. Then we're going to multiply these two things. 4 times 2 is 8. Then we're going to add these two and bring it down. Then I'm going to multiply the 8 times the 4 to get 32. Then I'm going to add. Then I'm going to multiply. Then I'm going to add. Put a little box around the last number like that. So that was pretty fast, but it's simple. Bring down the 2, multiply these, right it there. Add, multiply, add, multiply. Okay? Now, this is my remainder. This is my quotient. This is going to be the constant. This is going to be the x. This is going to be the x squared. And I've done the division. Now, I'm not going to spend a lot of time talking about why these are the same, but you can kind of see it here. If there's a 1 in front of this, then you're always going to put a 2 right there. That's just bringing down that 2. Bringing down the 2. Then, the only thing I know this is going to go away. The only thing I really care about is what is this number here. When I take that 2 times this 4, I get a negative 8. But then I got to change the sign to add it, so I make it a positive 8. Well, by putting a positive 4 here, I've already changed the signs. So 2 times 4 gives me the 8. Then I add the 8 and the 0. That's adding the 8 and the 0. Bring down that number. Whatever number gets brought down here, that's going to be the number that goes next. So you can kind of, well, whatever. Spend more time with it, or if you want to come talk to me, I'll spend hours talking about it. But in this video, we're just going to kind of know it like this, or do it like this, okay? So there we go. That's it. Let's do another one. Use synthetic division. So my factor is x minus c. This is x minus a negative 1, which gives me x plus 1. So my c value is negative 1. You always take the opposite of that sign. So 5, 3, no squared term, so we got to put in a placeholder, 0, 10, negative 2. Take out a negative 1. Bring down the first number. Multiply, add, multiply, add, multiply, add, multiply. So fast, so quick, so easy. This is my remainder. This is my quotient. X squared, x to the third. So if I take x to the fourth, 5x to the fourth plus 3x to the third plus 10x minus 2 all over x plus 1, I'm going to get a quotient of this plus my remainder over my divisor. So much better than long division. The problem is it only works if your divisor is a simple x minus a constant. If your divisor is a 2x minus 7, can't really use it. Now, if you're smart, you can kind of make it work with this one. But if you're x squared plus x plus 1, if that's your divisor, that's on the bottom. You can't use synthetic division at all. So, but use it whenever you can because it's so short and easy, quick and easy. Okay. All right, the remainder theorem. Okay, I've got 4 minutes. I'm going to have 3 minutes. I want to explain what the remainder theorem, I want to explain why it works. I'm going to start another video.